Good morning, everyone, and wonderful to have you all today for this webinar on electrical installation in hospitals, the safety measure. This is our 9th webinar by CAPE, who's been contributing to the knowledge on electrical safety. So today we are talking more specific to hospital. Today we have a very highly distinguished guest. Today with us is Dr. Vijay Agarwal, the president of CAHO. He will be doing the opening remarks. Dr. Vijay Agarwal, the president of Consortium of Accredited Healthcare Organization, was awarded the Kipro Platinum Standard Award in 2019 for healthcare by Kipro Foundation on 13 November 2019 at Mumbai. Kipro Platinum Standards awardees is one who is a national statement for quality and excellence with global footprint. Dr. Vijay Agarwal, a national crusader for continual quality improvement in healthcare, has a vision to raise the bar of Indian healthcare organization to match global standards through CAHO, which is a platform created for NABH, NABL, JCA accredited HCOs to share best practices, create benchmarks and training programs. Apart from facilitating continual quality improvement in these HCOs, CAHOs encourages these organizations to handhold and mentor other hospitals to join quality journey and accreditation. He believes that people make quality. Driven by this aspiration, passionate belief, he has established a series of CAHO certified professional courses to equip and train every healthcare professionals to pursue quality journey. Dr. Agarwal is a postgraduate in pediatric from Maulana Azad Medical College, New Delhi. He commenced his professional career in 1973 and has over the decades earned sterling reputation as a pediatrician. He will be remembered for his role in bringing pulse polio strategy to the country and for his strategic skill demonstrated while driving the National Pulse Polio program. Ladies and gentlemen, I now welcome our guest, Dr. Vijay Agarwal, to give his message.
Thank you. Thank you, Mr. Dominic, for your very, very elaborate and kind introduction. So greetings from CAHO. And I'm thankful to the organizers and to Mr. Dominic for giving me this opportunity to give the opening remarks for this very important webinar. Ladies and gentlemen, I call it very important because it is connected with the safety of healthcare delivery. Healthcare delivery is a basic need of mankind and has been important since time immemorial. The evolution of modalities to deliver healthcare has been truly mind-boggling. Every invention and change were aimed at making the healthcare delivery safer through quality healthcare. Every invention has been adding a tool in the hands of the doctors to cure more and more people with better and better outcomes. The advances in the field of medicine have reached such a level that many disorders which were considered untreatable are now controlled or cured routinely. And this should have been actually the golden era of medicine. But it was not to be so. Healthcare today has become very complex and resulting in increased amount of medical errors. Medical errors ultimately mean that patients are being harmed while being treated. The fact that medical errors are the third leading cause of death in a country like United States, you can well imagine what does it mean for a developing country with much less resources for a country like India. Now, besides patients dying from medical errors, we have incidents of fires, especially in the big tertiary hospitals, making the hospitals unsafe and healthcare delivery as unsafe as bungee jumping. The incidents of fire are on the increase, and the single most important cause of fire in these hospitals is the inadequate attention to the electricity supply and installation. These fires start in the hospitals, much more in areas like ICU and operation theaters, where there is a lot of oxygen supply. This particular webinar today is focusing on electrical installation and the safety measures in hospitals. It is extremely topical, and we could not have asked for a better expert than Mr. Gopa Kumar, who is a member of MT40, which is a prestigious technical committee of IEC, which is responsible for making the global standards for hospital electrical installations. The standard is called IEC 603-647-710. The recommendations are included in USA and all over Europe and developed Asian countries such as Singapore, Japan, etc. I am very confident that Mr. Gopa Kumar will really throw good light on this, and I think this is a need for all hospitals to understand the inadequacies which are resulting into major problems. So without much ado, I would like to now hand over back to Dominic or to Mr. Gopa Kumar, as you would like, sir. Thank you.
Thank you so much, sir. Thank you for blessing this wonderful subject today, the very important knowledge that Mr. Gopa Kumar is going to share. And I know you are one of the most busiest person as a president of CAO, and the next whole week, your entire healthcare are gathering in Cochin for the CAO conference. So I wish you all the very best for the upcoming important conference in Cochin. And I'm also part of it, so I look forward to see you. And thank you, wonderful sir, for associating. You are always, with short notice, you participate. That encourages, that inspired us more than anything. Your presence and your wonderful wisdom that you've given is blessing for all of us, sir. Thank you very much, sir.
Thank you so much. Thank you so much. Please.
Ladies and gentlemen, everybody is aware of Cape Electric, and as I said in the beginning, the continuation of sharing knowledge is the passion of Mr. Gopa Kumar, who's heading this Cape Electric, which is established in 1996. Cape is the first and front runner in various technology products in India, be it lighting protection or electrical installation materials. Cape technical seminars and webinars on lightning protection not only help industries in solving failure related to lightning, surges and earthing, but gave an in-depth knowledge about international standards. Providing solution is the motto, and hence the technical team in Cape Electric are continuously trained to provide end-to-end solution from design to implementation. I don't need to talk much about Mr. Gopa Kumar. Our keynote address, Dr. Agar already spoken about Mr. Gopa Kumar, and he has become a face of electrical vertical in the country. Anything related to electrical, it's all Gopa Kumar. So he's a strong member of National Building Code. He's a member of international committee. So what more? So I won't do this much detailed introduction of Gopa Kumar because you don't need Sachin Tendulkar need to be introduced in cricket. So it is like that, Mr. Gopa Kumar in electrical industry. Over to Mr. Gopa Kumar.
So thank you very much, Mr. Dominic. I hope my screen is visible.
Yes, sir.
So thank you very much, Mr. Dominic, for your encouraging words. Also, thanks Dr. Vijay Agarwal for giving the keynote address. Now, today we are going to discuss about hospitals and safety, not only fire, but the general safety in the hospital. The hospital safety worldwide, the mandatory rules of hospital safety has been made in the IEC standard 60364, part 7710. It's actually a part of the IEC standard called as 60364, electrical safety. Worldwide, across globe, this standard has been adopted in Americas, in Europe, or in all the developed nations. So in India, the same standard has been adopted as IS 1751. It's not 0512. I'm sorry, I made a small mistake while typing a little bit faster. Electrical installation, medical locations. This standard has been published in 2021. And this standard is in IEC, it's made by the MT40. MT stands for maintenance team, MT40 of TC64, where I'm a member. So basically the background of the standard and why each and every part of the standards or how it is explained is well known to me. So today we are going to discuss not the entire subjects of this particular requirement, but only few of the important subjects which is related to the hospital safety. Now, medical location. What do we mean by medical location? In a hospital, there are general locations and medical locations. Medical location, when we say medical location, that is a place where a patient or a person or a human being is treated, some kind of treatments. Probably, it is subdivided into group 0, group 1, group 2 locations. But medical location means it is not the general place. It is a place where people are connected with some kind of, or people can touch some kind of electrical apparatus. So as a result, what happens, in medical location, all of you know that electricity and electrocution shock, the resistance to body is primarily given by the skin, and if any metallic part bypasses the skin, resistance is too less. As a result, the conventional calculations are not applicable. Even a small current flow probably may be dangerous to the person. It can create burns, or it can create electrocution, heart stopping and all. So basically, in a medical location, a lot of biomedical equipment probably are bypassing the skin. As a result, very low resistances are applicable. Shock chances are much more. Also, shocks such as micro shock and macro shock, especially happening because of different electrical biomedical equipment connected to the area. Plus, the area is wet. Once when your body is wet, the resistance is less. As a result, the chance of shock is much more, or chance of burning is much more. Then in some of the areas in hospitals, it is oxygen enriched area, means the amount of oxygen, because say for example, an operation theater, oxygen is used. As a result, the oxygen content in the area is very high. I'm sure most of all of you are aware about the fire triangle. You need fuel, heat, and something to burn oxygen. If oxygen is more, the chance of fire is more. Then one of the requirement is supply continuity during fault, which I will explain later. Plus the other requirements are EMI, harmonics, and so on. So basically, medical locations are special areas where we really need to treat people, or really need to treat the electrical appliance very specially. We cannot apply the normal rules and regulations in a medical location. So in a medical location, what is the speciality? Due to a lot of electronic, the biomedical equipment are using magnetizing or self-inductance for its operation, normal operation. So sometimes you don't need to touch an equipment to get a shock. Current flowing through the insulation itself sometimes creates some kind of shock hazard. And the conductive parts, a lot of conductive parts are existing, and probably it is also connected to the human, like direct connection to an internal organ during measurement or a surgery. then external electrodes for temporary cardiac pacemakers, electrodes for intercardiac measures, then liquid-filled catheters. Then one of the worst danger is current flowing through the heart, and all these things can create burns. That means the body can, the surface can burn, muscle cramps, respiratory arrest, cardiac arrest, and ventricular fibrillation. These are the anticipated effects or minute effects which is going to happen in a medical location. One of the important physiological effect is microshock or macroshock. So a macro shock is applicable. For example, externally applied current spreads through the body. Probably if you are touching something, or probably if an appliance, a faulty appliance is connected to your body, such accidents can happen, and it may be a reason for a cause of death. So the influencing factors here are skin and body resistance and the design of electrical equipment. So both these micro and macro shocks are very dangerous for a medical location. Now, in order to reduce the accidents or the amount of the problem, different standards are recommending different requirements. So say, for example, the NFPA 99, which is followed in America, it says in general areas under normal condition, more than 500 millivolt shall not be allowed, and in critical areas, 440 millivolt in normal condition shall not be allowed. That means you have to, all the exposed and extraneous conductive parts must be interconnected in such a way that more than this voltage does not experience between two metallic parts. The NEC 2011, NEC, I mean, this is the National Electrical Code of India 2011, Part 3, Section 4, medical locations. This particular code 2011 explains about the requirements very well, very in a detailed way. So according to this particular standard, under certain areas, a voltage of less than 10 millivolt under certain conditions is also necessary to avoid shock hazard. Similarly, the new standard IS 17510, the 1751, the medical location standard, the new one, 2020-21, clause number 6.1.3.1.1.1, disconnection of supply in group 1 and group 2 medical locations. The standard says the nominal touch voltage, the conventional touch voltage shall be lesser than 25 volt. Conventional touch voltage is not in normal condition. This is in a fault condition. That means probably you have a faulty equipment, or you have a faulty electrical wiring. Under that condition, under a fault condition, the maximum allowed touch voltage in group 1 and group 2 medical locations are lesser than 25 volt, or before the voltage reaches 25, we are supposed to disconnect the supply. The table 1 of the same IS standard says, for general location, we are supposed to use a TN system, the disconnection times are given. Also the IT system, disconnection the disconnection times are established. This means you should, if you carefully look into this particular table, what is missing is TT system. So we are not supposed to use a TT system in a normal application. TNS is recommended in IS 17512. I'm sorry that I have put as 17510 as somewhere. That is mistake. 17512 is the correct standard. So basically, TT systems are not recommended in the medical locations or in the hospital. We always have a confusion. What exactly is this, the TN system or TT system? Because, for the safety, the first point is what kind of system earthing you are doing. Now, with respect to safety, system earthings are classified into two. The first one on the left side is an electrical installation where safety is achieved by disconnection of supply. Disconnection of supply in the sense, in case of any fault, the supply must be disconnected within certain time. Before the touch voltage is harmful to a human being, the supply must be disconnected. This is the safety measure number 1. It can be used in general locations, and this is also called as the earthed power supply. The application number 2, continuity of supply. What does it mean is, in a hospital, especially in a group 2 medical location where operations or the patient is connected to various biomedical equipment. Imagine you are putting a new device into the circuit which is having a faulty. Without knowing the problem, you have put the device into the circuit and the MCB tripped. So if disconnection happens in that kind of an area, the patient will be in danger because the supply itself has been disconnected. For that application, especially for application in group 2 medical location, continuity of supply is important. What do we mean by continuity of supply? Continuity of supply means even if you use a faulty equipment, or even if there is a first fault, the supply shall not disconnect. The supply shall continue. So also for fire services, for firefighting systems also, you can use for the technique called as continuity of supply, which is called as unearthed system. So basically, electrical systems are classified into earthed and unearthed system. Earthed system means your MCB should trip immediately. Unearthed system means your MCB need not have to trip during the first fault. So with this understanding, I'm showing you a picture which is a TNS system. I'm sure most of the engineers are, those who are attending are engineers with a medical background. I'm sure they know how the system is implemented in a typical hospital. What I am showing is a TNS system. Means you have a source. The source can be a DG or the source can be a transformer. You have the 3-phase coming from the transformer. You have the neutral, which is also distributed into your electrical installation. Now, what you should understand is, you look at the picture, the green wire electrical installation is connected back to the neutral of the source. So this is a TNS system. Basically, it's a 5-wire system. And the neutral is also earthed, which is a functional bonding. Functional bonding in the sense, in order to create a stable voltage in your electrical wires to earth, a functional bonding is created. So basically, this is called as a TNS system, means a 5-wire system. Neutral shall be strictly earthed only at one place. That means strictly only at one place. You are not supposed to connect the neutral at multiple places, then you will have bigger problems. The protective earth conductor, the 5th wire shall run parallel to the line and the neutral conductor to avoid large loops, and the fault loop impedance of each and every circuit or each and every distribution final circuits must be able, the protective device must be able to disconnect the supply. So it is not only a TNS system. TNS system, in simple, people think that, okay, you make 5 wires and you make a TNS system. No, it is not like that. A TNS system followed by all the conditions of TNS must be followed. It also means our general concept, what I am showing you is a source. Imagine it is a transformer or a DG. Neutral is connected to an earth electrode in soil. And then you have your electrical installation. Imagine some kind of a load, a biomedical equipment which is connected to the power supply. The equipment vendor is asking, I need a separate earth. As a result, what people do is the body of the biomedical equipment is connected to a separate earth electrode. Actually, this is not allowed in hospitals. It looks like a TT system, but practically in my experience, the hospitals, those who are following this kind of a system, means each and every part of the electrical installation, such as some of the biomedical equipment, sometimes isolation transformer, sometimes UPS, sometimes electrical DBs, and each of the transformer and the DG, 2 for neutral, 2 for body. So such system is actually not allowed in hospital, and it is completely wrong. We are supposed to follow a TNS system, a proper TNS system. Similarly, for group 2 medical location, we can also go for IT, means insulated, isolated supply with insulation monitoring devices and the leakage current monitoring system. Say, for example, IT system means you have the source, probably an isolation transformer, then the secondary side of the isolation transformer, line 1 and line 2 with a voltage of, let us say, 230 volt. These two lines are completely insulated. So these two lines are never connected to earth. So it is completely insulated. Now you have an insulation monitoring device and all this, this entire system, sometimes it's called as a hospital IT panel. So hospital IT panel for group 2 medical location is one of the several other requirements. What I wanted to tell you is, don't think that by making a hospital IT panel, you achieve the entire safety. No, it is not like that. You have to have so many safety measures. One of the safety measures is medical IT system. But whenever it comes to earthing system, actually the first part which we are missing is earthing. And everywhere, so many earth electrodes. There are hospitals with more than 150 to 200 earth electrodes all around. So we make a kind of an earth farm. So earth farms are a clear violation of the safety, and it is one of the main reasons for non-disconnection of supply resulting in fire and shock hazard. Please don't make it. Also, then what you should do, you should clearly follow the rules of IS 732 and the IS 17512 to achieve safety. Also, don't believe in magic boxes. There is no magic box which can ensure electrical safety. What I mean to say is, in the market, 2 weeks back when I was visiting a hospital, they told that they have bought a new product which will offer all kind of electrical safety. Whatever safety you need, this particular black box offers it. So actually these such black boxes cannot offer any safety. Please don't follow such things. You should follow all the each and every rules and regulations of these particular standards. Also, a lot of hospitals are doing thermography in the final wirings to ensure electrical safety. But in the last slide, I will explain you what kind of testings are required. Thermography, unfortunately, is not recognized for low voltage electrical installation as a reliable testing measure. Then what do we need for earthing? As I am showing in this particular picture, the correct way of earthing is called as main equipotential bonding, supplementary equipotential bonding. Main equipotential bonding, as you can see in the main, in the picture which is at the center, at the mains incoming panel, we are supposed to make an earth bus bar, and the exposed and extraneous conductive parts must be connected to this particular bar. Then at the sub node, let us say, for example, operation theater, you are supposed to have supplementary equipotential bonding. On the left side, you can see how the supplementary equipotential bonding is made. You have to have a bus bar larger enough to accommodate each and every connection separate. So individual earthing means each and every medical item must be connected to this bus bar separately. This means you are not supposed to make a loop. Then you can see here some of the biomedical equipment are connected. The medical IT system is connected to the bus bar. The cable management system is connected to the bus bar. The floor mats, electrostatic mats, or some mats, if it is available, is also connected to this particular bar. The lights, the monitoring system, and whatever the medical gas, the other extraneous conductive parts such as the wash basin or whatever, all the metal parts in that location is connected to a common bus bar, and this is called as supplementary equipotential bonding. One of the first and the foremost electrical safety requirement in a medical location is to have a supplementary equipotential bonding. In the picture, I am just showing how to make it, but there are several rules to be followed. Say, for example, after making the supplementary equipotential bonding, let us say, for example, this particular medical pipe, the gas pipe and the bus bar, the resistance between the medical pipe and the earth bus bar must be lesser than 0.2 ohm. So measurements are required, the joint measurements are required. So basically, the rules for supplementary equipotential bonding is very much mandatory for medical locations, group 1 and group 2 medical locations. Please don't follow the medical equipment vendors claim for having separate earth electrodes. Separate earth electrodes are wrong. This separate earthing, if they claim, is something like from their equipment to the supplementary equipotential bonding, you need a separate wire. So this is much more efficient, and of course it is very much cost saving, very much economical. So this is what is recommended in this standard. Now, medical locations are classified into group 0, group 1 and group 2 medical locations. So group 0 medical locations where medical electrical equipment can be brought into contact with the patient or need to be touched by the patient, but basically the applied parts are not intended to be used. Medical locations where no applied parts are intended to be used is called as group 0 location, but it doesn't mean that the person is not allowed to touch the electrical appliance. Yes, of course, that is allowed. Now, group 1 means a location where medical equipment is used externally, the applied parts are used externally, and the group 2 means the medical, the applied parts are used internally, means sometime, it is bypassing the skin and the equipment are going into the body. As I said, once when the skin is bypassed, the resistance of the body is quite less, so you have to be very careful. So the first point is the medical locations are grouped as per this particular group 0, group 1 and group 2 medical locations in the standard. The next is the applied parts. Applied part means the part of that particular medical equipment which finally is connected to the body of a person. So there are earthed parts, earth insulated parts, and earth insulated parts floating. Earthed, that means you have the applied part. It can be an earthed applied part, unearthed applied part, completely insulated earthed part. Anyway, this is the responsibility of the medical equipment vendor. You don't need to be bothered about this particular thing, because the medical equipment vendor, according to he has to categorize his equipment according to this particular requirement. But when it comes to the electrical installation, what is required is, I am showing you the table B1 of IS 17512/2021, examples for allocation of group numbers and classification for safety services in medical location. So here on the left side, you can see some typical examples. For example, massage rooms, what you should do, delivery rooms, how to categorize. Say, for example, anesthetic room, it is a group 2 location. Operation theater is a group 2 location. Then heart catheterization room is group 2 location. So basically, this table B1 of IS 17512 will give you an idea of the categorizations group 0, group 1 and group 2. Please note that this standard can be downloaded from the Bureau of Indian Standards website at free of charge. So you can download it, and it's only a few pages. It is not a very big document. It is only a few pages, probably 20-30 pages. You can go through it. But please also be sure that this IS 17512 to be read along with IS 732, because I would say it is a sub standard of IS 732. You should read both the standards. Now, the National Electrical Code 2011 also gives you some indication of the kind of protective provisions required in a hospital, in a medical location. However, the NEC will be replaced, 2011 will be replaced by probably an NEC 2022 within 2-3 months. But I would recommend that this provision of NEC 2011 also can be followed, because it gives information a detailed information is provided. So different safety provisions are recommended in the standard, starting with P0, P1, P2, P3, P4, P6. You can see it here, different provisions, and the explanations are provided. I will just read P0, P1, P2 and P3. P0 means duration touch voltage restricted to a safe limit. This is by installation TNS, TT or IT system. But as I said, nowadays TT is not recommended. TNS is recommended for medical location. P1 is P0, touch voltage patient environment restricted to a safe limit. What does it mean? It means the touch voltage is lesser than 25 volt. P2, additionally, the touch voltage is reduced to less than 25 volt. Resistance between extraneous conductive parts and the protective bonding conductor bus bar of the room shall not exceed 0.1 ohm. Now, in the new standard, this has been a little bit modified to 0.2 ohm. But this how to measure is also equally important. If you take a multimeter and measure the continuity resistance, of course, you get erratic values. You have to have a very good, high quality micro ohm meter to make this particular measurement. Then P3, I don't want to read much into it. So different protective measures, provisions are recommended in the National Electrical Code 2011. So additional protective provisions. I'm just showing you just to give some information to you. This NEC 2011 also is freely downloadable. You have to go to the BIS website, make a username password, and you can download it. Of course, NEC 2011 is a big document. You have to go to part 3, section 4, medical locations. Now, the same standard explains you with respect to the recommended protective measures for each and every application. The hospital is categorized into various rooms. What kind of the provisions necessary for each area, P1, P0 to P7 is also provided in the standard. Say, for example, anesthetic room, P1, P2, P0 and P1 is mandatory. P2 to P5 you can make as an additional safety provision. So I skip these slides because sometimes, in a presentation, making it too much theoretical or theory will be too much boring. So you can download it and you can read it. Please try to understand it. Then in the new standard, the IS 17512, special requirements for group 2 medical locations. Here, the requirements are very much, modified. The first thing is you need to have a medical IT system in group 2 medical location. The requirements are given in this list. Once when I share the video or once when I share the presentation, you will be able to understand and you will be able to read it more. What we will do extra is we will make a blog in our website, and the blog also will be shared to you. As a result, you will be able to understand and you will be able to download all these documents. So here, medical IT system, the internal AC impedance, the test voltage, and all these requirements are given. Then again, medical IT, in case of fault, in case of a single fault, what you should do, or in case of any insulation resistance reduction, what is necessary is also very well documented. Now, the other requirement, so for the last 2 slides, I was showing about the requirement of medical IT system. That means the OT panel, which you generally call, is one of the safety measure. But the additional safety measure is the ME and the ME system. Medical equipment and medical equipment system shall be designed and tested as per IS 13450. This is a new standard. It is, of course, from the IEC standard. Please ensure that all the medical items which you are buying and using in your hospital, they are conforming as per the IS standard. You can also refer to the respective IEC or sometime, European products, the EN standard, but check that it is equivalent to the IS standard. Then on the second para, what you are seeing is these systems, the medical equipment and medical equipment system, once when you put a new system into your electrical installation, or if you do a repair or maintenance or some kind of reconnection, you are also supposed to do a testing as per IEC 62353. There is no equivalent Indian standard yet. So this particular standard, what does it say? You are supposed to test the resistance of protective earthing. Means You have from the equipotential bonding bar to your equipment, you have a wire, earth wire. The resistance of that wire must be lesser than certain limit. So you are supposed to measure it. Measuring of insulation resistance is required. Then equipment leakage current to the equipment and applied part. These three measurements are mandatory in every biomedical equipment or ME and ME system after you or once when you connect or reconnect into your system. The next requirement is oxygen-rich environment. So as I said, oxygen-rich environment, the chance of a major fire is very high. So medical equipment used in that area must satisfy a lot of special and specific requirements, such as the temperature of the material is rise to ignition temperature. No, before that you are supposed to disconnect all these things. So these requirements are necessary under normal condition or single fault condition. What is single fault is, an appliance is faulty. Even under that condition, these requirements must be met. Similarly, the additional requirements for oxygen enriched areas, it is not one or two requirements. There are several requirements. I don't want to read all the requirements to you, but as I said, I will put it in the blog. You can download it, and in case of any questions, you can get back to me. We can have a discussion, or I can explain to you. Again, additional requirements of medical equipment in oxygen-rich areas are also shown. So what I wanted to tell you is designing a medical location, electrical installation in a medical location is not that simple. You have to understand the standard, you have to understand the requirement of each and every requirement, and you should do it properly. And the final part is testing. In any hospital, the testing which is recommended in the IS 732 for general locations is very much mandatory. There are 19 inspection points and about 10 testings. Of course, there is one more which is called as a PAT, portable appliance test. These tests are very much mandatory. And for the medical location, as I said, the additional safety features are required, such as a TNS system is mandatory. That means the person who is doing, he should be able to find out, he should be able to understand what is TNS, and he should check and find out the integrity of TNS system. Automatic disconnections are necessary. Then special requirement for group 2 locations. Then the touch voltage under normal conditions need to be tested. Then the current loops. Say, for example, once when you operate some equipment which is creating a kind of leakage current, or sometimes some kind of electromagnetic influences, parallel paths also may have a current flow which can create problems. So all these things must be tested. EMI has to be under control, otherwise unnecessary your electrical communication system will create problems. And the last one for medical location is additional test. In the normal electrical installation, you need to have the 10 different tests, and the medical location, you need to have the additional test. The first one is the functional test of medical IT system. Then the second and third are related to the equipotential bonding, supplementary equipotential bonding, and main equipotential bonding. Then, the changeover system, you need to check whether leakage currents are within the limits and so on. So all these additional safety measures are also necessary. So what I wanted to tell you is, or what I wanted to convey is, safety in medical location, it is not achieved by, by implementing one measure. There are several measures. So all these measures must be implemented in order to achieve safety. Now, what we offer in CAPE, we are capable of offering the entire solutions, starting with the risk assessment as per the ISO 14971, which is actually in medical areas, there are chemical things, biomedical things are there, wastes are there, how to handle it, and in case of accidents, how to solve the issues are included in the ISO. In this particular ISO, you have to make a risk assessment. Implementation of TNS system with the protective equipotential bonding and supplementary equipotential bonding. This we are doing already in several hospitals. We carried out this. Medical IT panels for group 2 medical locations, because once when we offer all the services, medical IT panel is also one of the requirements. So this also we are offering. Then periodic verification and training of biomedical engineers. What we are doing is periodical verification. Sometimes you may have to check your UPS and your generator once in 3 months or once in 6 months. So calling somebody, a third party, and doing this test will be quite difficult. Also, imagine you are having a new equipment every time. Depending on a third party will be very difficult. So we train your engineers, or we train your biomedical engineers to handle the day-to-day needs of the technical requirements. Compliance to IEC 62353 for medical equipment and medical equipment system. Then EMI and protection against temporary over voltages. As you know, most of the time the electronic equipments are failing due to small issues. If those small EMI issues are handled well, you will get the life of the equipment will go very high, and without any accident you can enhance the life of the equipment. And the compliance to the standards IS 732 and IS 17512 can be made. So these are the safety measures which we are offering. Then we have made a website. Actually, we are working on a kind of artificial intelligence, AI in electrical safety, which is probably very new. We are working since last 1 year. People ask how AI can help in electrical safety. Of course, we are building up a large database. This large database will have, let's say, for example, a client or an user wanted to know why the MCB didn't trip. A simple question. So once when you log in, once when you ask this question to this software, the software tells you, okay, there are 10 reasons, and it will ask maybe 1 or 2 questions. And if you give some simple answers, the software will be able to tell you exactly what is the problem with which the MCB didn't trip. Similarly, we are trying to make it mostly for the investigation purpose. Whenever there is an accident, the investigations can be done with this particular software. We are working on it already last 1 year. So AI in electrical safety. And we have made a website specifically for that, which is called as SOLVE. SOLVE stands for Safe Operation of Low Voltage Electricity. SolveLV.com is the website. You can go to the solutions. You can go to the sub page, which is special locations. You can find the special services available, and the medical is one of the special location, and you will be able to find out the requirements of the medical location in our website. So you can go to it, and this website will be useful for you to understand some information. But parallelly with, after this program, we will probably tomorrow or day after tomorrow, we will make a blog exclusively with these requirements so that it will be more clear to you. So by this, I would like to stop my presentation. Thank you very much for listening to me. We actually have a large group of people, more than I think 180 participants are there. So thank you very much. Over to you, Mr. Dominic. We can go for a question and answer.
Yeah. Thank you. It was a quite short presentation, as normally we take 1.5 hours. But very insight information that you have given, Kumar, about how to solve the issues of the current hospital and how CAPE can help the healthcare industry in solving this problem. So we have few questions as of now. I would request everyone, if you have any specific questions, so please post in the Q&A box. And we have almost 8 questions here. So we would like to have this program more interactive, understand your any suggestions, any queries we would like to address today. So the first question, our Narsinga Rao, who's regular in all our webinar series, his own question is, what is the amount of heat and temperature required to ignite the fire in an electrical installation?
Actually, there is no fixed temperature for that. It depends on the kind of materials which is going to start the burning. So it can be anything, probably even 100 or maybe 300 to maybe 500 or 1000. So there is no fixed temperature here. It depends on the equipment.
Yeah, you're very right. So it can be anything. Plastic has a different temperature, wood has a different temperature, paper has a different temperature. So it varies from material to material. So yes, this whole recording PPT will be shared to all of you by Monday or Tuesday. So you will get the link in your mail that you have shared here today. So Riaz Ahmad Qazi from Hyderabad, how to check my equipment is appropriate earth or not?
See, you have to measure the resistance. Resistance in the sense the continuity resistance. Imagine you have an equipment that connected to your power supply. The resistance. This is actually applicable for class 1 equipment. You must understand that electrical equipments are classified into class 1, class 2, and class 3. This is safety earthing is required for class 1 equipment. From the earth bus bar or earth terminal of your equipment to the earth bus bar of your incoming power supply, you are supposed to measure the resistance with a micro-ohmmeter of, let us say, 10 amps current, and you should see that the resistance is lesser in the sense, imagine the connected wire is 4 square millimeters of wire and the length of the connection is, let us say, 20 ohms. So 4 square millimeters of wire have certain resistance into 20 meters. So you should the resistance of the wire multiplied by the length you can calculate and you compare with the value. This is how it is done.
Oh, we have another question. This separate earth pits misbelief needs to be busted in a big balloon. So he's very strongly urging that having a separate earth pits misbelief needs to be busted in a big balloon. How do you react, sir, for this?
Yes, actually, in my view, that is the biggest problem in India, because a lot of engineers think that the earthing means in the earlier days we have the Britannia advertisement, light up like a bulb which was glowing. So people, if they listen to the word earthing, immediately they think that it is a pipe in soil or it is a plate in soil. So which is wrong. Earthing means the measures which is taken to reduce the step and touch voltage. That's it. Yeah.
Okay. So what is role of SPD for hospital? I don't know, what is that?
Yeah, SPD is called as a surge protective device. SPD has got a large major role in hospital because I would say not only SPD, shielding, cabling, screening, and SPD. That means the entire measures to protect the sensitive equipment are important. SPD is one of the part in all, in the whole transient over voltage protection phenomena. Simply putting an SPD probably may not be useful. You have to understand it and you have to put it appropriately. Of course, SPD is a very important component for hospital because you have a lot of highly sensitive equipment. So you require the protective measures such as SPD, screening, shielding, bonding. All the 4 are required.
So how do you ensure that these 4 are done it by the contractor or by the installer? So is there any way to check or something?
There is no way to check. Actually, these are installation practices. You have to. The only way is you have to have a deep knowledge into the technical requirements of the standard, and don't violate it. It's simply follow it. What is written is simply follow. So basically, there is no, of course, testings are there. SPDs can be tested, screenings can be tested, but it will be very difficult to explain, in a short way.
Good. Sanjay Mulay is saying, if I am not wrong, TNS system is not used in normal industrial installation.
Yes, that is also quite unfortunate. TNS system is not, even though it is recommended TNS system is not used in industries, but now the awareness is more. People will start using it. Earlier there were no forum which was explaining how a TNS must be made, but nowadays after our trainings, a lot of people, lot of organizations start explaining about TNS system, and of course over a period of time it will come.
Yeah, Mahesh Desai is put a question. I'm not very clear about it. I'll just read out. One of the incident came to know from investigation lab that during MRI, person came to know incident and died. What might be the reason? So the question is not properly worded. One of the incident came to know from investigation lab that during MRI, person came to know incident and died. What might be the reason? So Mahesh Desai, if you can put that question once again properly, we could probably able to tell you. So I'll move on to Syed Bakar Hussain. What does NFPA recommend for suppressing fire in MRI and other lab in hospitals? So we normally recommend, our water mist is something that we can use, or we have a clean agent. So normally the clean agent is done through external cylinder, external piping, and bring in with our tubing system. And so this is something which is normally recommended for MRI and other lab. Of course, if you have aspiration system, very early detection system, which also is used for detecting the smoke and water mist, and the clean agent system is what is advised. So Prakash Kamath, if we can build an atomic station with zero error and oil and gas installation with almost zero error, why can't we build hospitals with zero error as a regard to safety? Completely agree with you, sir. I don't agree with people who claim that medical charges work out already high and safety costing increasing it further. Gopal, you're saying everything can be zero. Why not hospital? A wonderful question. Whom should we, address this to? Hospital management, or the doctor who's practicing? Can he demand the management as a, practitioner every day? I keep seeing many hospitals, even doctors are not aware of the safety practices that is been, implemented in the hospital. So in many cases, there is no detection system, there's no sprinkler system, even the electrical room, whether it is protected or not. So somebody should, raise this question to the management. If the safety consciousness come and demanded, I'm sure every hospital can be zero accident. But over to you, Gopakumar, you have anything to say on that?
Yes, of course, probably zero error will be too high, but a very, very high degree of safety can be achieved. Let us say 99.99%. But I was, during this COVID time, I was doing some kind of audits in hospitals. I visited at least, several hospitals, which those who are having LT connection, HT connection, and so on. I also did some comparisons and webinars earlier. Out of, let us say, on an average, how many hospitals these measures are implemented properly? I would say probably 1% or 2%. That's it. More than 50-60% of the hospitals, the basic requirement itself is violated.
If any of our participant wants to, communicate, you want to talk here, we can allow you to, have a dialogue in person. So you raise your hand. My colleague Lakshmi will allow you to speak. So you can just raise a hand if you have something that you want to talk to Gopakumar in detail. Lakshmi, on the participant on the right side, you can say, allow the participant to speak. So people are raising, 5 people have raised, so you can allow them to join in. And so I will go to Firoz. Firoz, you have something to say, you can unmute and speak. Firoz, can you unmute? Yeah. Go ahead, Firoz. Firoz, we can hear your background, but would appreciate that if you can speak, or if you don't want, you can mute the speaker.
Yeah, okay.
Yeah, we can hear you. Tell me, Firoz.
Sir, my question is, which type of use electricity fire hazard in fire extinguisher?
It depends, sir, where you want to use. CO2 is what is used in our electrical panel. We have a tubing system used with clean agent in electrical panels. So what type of extinguisher, you can write to me. My mail ID is given. I can send you a document type of extinguisher used for different materials, so that I can share you later. Okay.
We go to the next activity, sir.
Yeah, you can allow one by one, and I'll go to the next question. Mahesh is asking, how can we control electric shock?
Very simple. Potential difference is creating electric shock. If there is no potential difference, no electric shock.
Very simple answer. So Tara, can you hear me? You can probably.
Yeah. Good morning, everybody. It was a very lovely presentation, and really we are enlightened. I have got a general question. Basically, we are working mostly in government hospitals in government of Odisha. So there we are working with PWD, who are making a huge scale of hospitals, cancer hospitals, trauma hospitals, mother child's teaching hospitals. So there we are facing a difficulty because all the equipments are being purchased after the building is completed. So the purchase is being done by some other agency. It's not R&D. So it is very difficult to align the electrical system for the equipments, particularly for specialized hospitals like say cancer, PET CT, MR, all the mother child facility, or trauma facilities, neurosurgery facilities, orthopedics. So we are facing this difficulty. Our MEP consultants and the design of the building and the equipments procurement, they are not properly aligned. So what we got the comprehensive idea about from your presentation is that it must be going together. Otherwise, it is very difficult to go for a zero error strategy for the equipments and for other safety precautions, whatever you said. How to address?
So thank you very much for the actually an very interesting question, sir. I think such questions we need to address properly. It doesn't mean that other questions are not addressed properly. Sorry for that. See, there are two things. One is you have the building, or let us say the electrical installation. Later, you are going to use equipment. You are going to connect the equipment. So these two things must be handled separately. Whatever I was explaining is predominantly the electrical requirements in a building. That means in a hospital. That means in a medical location. Now, if your medical location is electrically equipped to handle the electronic equipment, then the second part, you are buying the electronic, let us say first part, you are constructing the building. The MEP designer has made all the provisions of safety in the building. So the contractor has installed all the provisions for safety, and the person who is doing the testing also tested for all the provisions. Then the second part is only the medical equipment. You can buy it probably after some time, after a few years, because your installation is going to be constant. You are not going to change the room later on. So equipment can take, it can be second purchase, or it can come maybe after a few years. Nothing happens. Now, these equipment also satisfy additional requirements. So both are required. And we need not have to club the installation requirement and the equipment requirement. It can be separate.
Here I would like to say something. That most of the time, our client or the user department, they are not able to provide us a comprehensive equipment requirement for most of the hospitals. So we need to follow the IPS guideline for that. So many places, some are with a raw voltage, raw current, some are with UPS supported. So we are really in a very, very dilemma how to go ahead.
I would say, sir, the system need to be improved. Very simple, system need to be improved so that all the requirements are handled very well.
Exactly.
You know,
because
we cannot change the system. Please go ahead, sir.
Exactly. In fact, it is not possible to change the system overnight, but we want to attain my maximum accuracy. And listen, sir, in PG postgraduate hospitals or general MBBS 650 capacity hospitals, teaching hospitals, or the super specialized hospitals, their equipments play a very, very major role. And in such case, without providing the equipment specification, if as per you, we are going for the electrical installations as per the specified rules, I have failed grossly to go for accuracy in minimizing the errors.
Thank you, sir. I will move on to the question from Sukhdev. How often need to test the earth bit for medical equipment which was earth? How often we need to test? Yeah.
If you are talking about the resistance of the earth electrode in soil, I would say you need not have to test for the purpose of safe operation of medical equipment. No test is necessary and no test is mandatorily required in any standards. You don't need to do it.
Okay, I'll move on to Ramakant Sharma, who is listening to us. Ramakant, please go ahead and put your question.
So am I audible, sir?
Yeah, very clear.
Sir, I wanted to ask you that I'm associated with a very big hospital of 1200 beds, and it has got a very big campus in 84 acres, and there are only one electrical engineer is there. So testing of equipments as per IS 732 and additional safety as per IS 17512. Then additional testing from IS 17512, is it mandatory, sir?
It is 100% mandatory. 100% mandatory.
Okay. But the inspectors who are coming from the authorities, government authorities, I think their auditor is only pressing more on the fire norms, not on this electrical safety policy.
Yeah, you see, the problem
and
is...
and that's why this area, electrical safety, is very gray in the hospital. Neither doctors know, nor the dean knows. The engineer, only one engineer is there, and such a big hospital and medical college is there. So we are finding very difficulty in coordinating and getting the systems tested as per the requirements, especially in the oxygen-rich environment areas.
I think it's a very difficult situation to handle.
I think that software which Mr. Gopakumar solve. So probably if you use that tool, probably if you can introduce to the management. So it's a small software which you can check yourself, and that it's a very handy tool that they have developed. So I think you can have a private chat with Mr. Gopakumar to see how, having one electrical engineer, maintaining 1,200 bedded hospital, impossible. That's very, very impossible. And as I said, yes, fire safety is given more priority than the electrical safety. But people don't know electrical safety. Sometimes if you ignore, that is the one which causes the fire. So,
and that's why the hospital more of the electrical accidents are occurring, because the authority is also not pressing for the electrical audit. They are only going for fire audit. Have you done fire audit? These are the questions they are asking auditors.
Even the
Actually,
fire
I would like
auditor doesn't go detail on the electrical equipment. Fire auditor will only talk, check on the National Building Code followed, or the NABH recommendations and followed, but they do not go on the electric. But however, you can have a one-to-one talk with Mr. Gopagan. I'm sure he has some solution for your hospital management.
I would like to add one more point, Mr. Dominic. The point is, see, the electrical inspectorate of the state government, their mandatory testing is required only for
coming once in
notified
a year,
voltage and
and
above.
sometimes they are not coming also.
No, because hospital is low voltage, which is under notified voltage. So legally, they need not have to test. It is the responsibility of the user to do it, not the electrical inspector.
These are the problems that the user, I told you that it is 1200 bedded hospital and only one electrical engineer is there. So he didn't get the time to do, even I am forcing him to do audits, electrical audits and all. So
I
this
think
is
the
a
solve will
condition
solve your problems, sir. That's what I would say. I think you can go in detail about that, the software that he has developed for electrical safety. It will help you, sir. Thank you, Ramakant. Moving on to the next question, Narsingara, again, dear sir, what are the functional tests which are to be conducted as a part of safety audit? Any meter are there for testing these functional tests? Please explain.
So there are several functional tests. First, we should understand the protective devices used and the function of those protective devices, such as relays, such as like fuses and all. And each and every protective device has got an associated test. So the different meters, sometimes fault loop impedance meters are required, RCD testers are required, leakage current monitoring is measured. So several different meters are required for that. We will explain it probably in another session in detail.
Okay. Thank you. Karthikeyan, if you are listening, you can unmute and speak.
Yeah, good morning all. Good morning, Gopakumar sir, for your wonderful session. I have a doubt in your one of the slides, so which is similar with my office setup. One of the slides says it is installed like 10 to 20 earth bits near to near. So we have an facility building. We take care of all the UPS supplies and the transformers. So we are together. It's a legacy setup, I would say. It's a 25-year-old setup, but we are serving racks to customers by UPS source as a single phase supply. So what kind of risk is there? So if I would skip this, or I should take an initiate to replace the earthing in some other distance. If yes, what would be the minimum or maximum distance?
So you mean to say that you have a building with a lot of earth electrodes and you are supplying single phase supply to your consumers, sir? Am I correct? This was the 2 points.
Yes, I would clearly say it is a data center.
Okay. Yeah, I understood. So in this particular case, see, number one, making separate earth bit transformer, neutral body, isolation transformer, UPS, all these separate to earth bit. That itself is, anyway, we need not have to talk about it. Very simple answer is it's wrong. Number two, you are supplying power to your consumer. Tomorrow, if the consumer is coming with a faulty equipment and connecting to your system, you need to ensure that your protective devices are disconnecting. If you have separate earth electrodes, probably the OCPD kind of protective device may not trip, which may lead to an accident, probably a shock accident or fire. You need to take care of it. So now I would recommend that you make the system a TNS, a proper TNS system, so that you are sure that your devices are tripping.
Since it is a legacy site, customers are critical. So during, say, for example, I would say if a UPS, we have two dedicated earthing for one UPS system. If I if something are identified or something are not identified. If in the live case, if I touch the earth and I'm rerouting and I'm reinstalling a new earth pit and connect to there, so what would be the impact? If that will disturb my load or what?
If you connect your equipment to one more earth bit, nothing is going to happen other than getting some mental satisfaction. Electrical satisfaction, definitely it won't help in any way. But if you wanted to see that your devices are not tripping because your the load is a data center, what you can do is you can go for an IT system. The secondary side of the isolation transformer, you can implement an IT system with the insulation monitor, so that even if the client connect a faulty device, you will get an indication rather than tripping. That way you can handle it.
Thank you, Karthikeyan. I'll move on because many questions and others are waiting. So I will move on to the question from Krutivanti Nasimha Rao. So do ELCB as practice to be installed in operation theater equipments?
Yes, as an additional measure, yes, because I think also the ELCB with a very lesser residual operating current under certain conditions are necessary. Yes.
Okay, I will move on to Abhinay Singh. You can unmute and speak, Abhinay. Abhinay, can you hear me? Abhinay Singh. So I'll move on to Sanjay Mule. You can unmute and speak.
Yeah, thanks Gopukumar and Dominic for the nice session. We really appreciate the way you are taken up the subject very and creating a lot many awareness. My question is that Gopukumar, everywhere when electrical inspector comes, he always take the objection on when I connect earthing system between lightning protection and equipment earthing connected to each other. They said no, it need to disconnect it now. Now the question is that, is there any provision written in IS 732 where I can convince these guys that it can be connected each other, equipment lightning protection or lightning protection and equipment can be connected together, and it will really make a lot of benefit out of that instead of segregating it?
Of course, this segregation is absolutely not correct. You have to interconnect and with a very short wire. I would request Mr. Appavu, who has also raised the hand, to answer to this question. I would like to introduce Mr. Appavu. He is the retired Chief Electrical Inspector to Government of Tamil Nadu. Appavu,
Yes,
sir,
yes.
please.
Thank you. Good morning, Mr. Dominic and Mr. Gopal. You are doing a wonderful job. Sir,
I think, sir, your audio is breaking. Your audio quality is poor.
Appavu, sir, your audio has broken. We are unable to hear you.
So meanwhile, come back, Gopakumar.
Yeah. Mr. Sanjay, actually, IS 732 is talking only about the low voltage system.
Yeah.
Whereas if your question is about a high voltage system, especially the 11 kV, 33 kV and all, you can go to the safety regulation part number 70, the regulation number 74.
Mm-hmm.
But more than that, there is a new IS code which explains how to connect the earthing of surge arrestor in the overhead line, or not in the overhead line, the substation. Probably I can send to you. You can refer that.
Yeah,
Connecting
please.
separate to earth electrode is absolutely wrong.
Yeah. That I convince only. These guys are not getting convinced. So what I do, in front of they I disconnected. Again they went back. Again I connect back to this system. That's what I'm doing. But my management says, Sanjay, they objected. Why you're doing like this? But I said, this is not the right way. Okay, if you send me something document, Gupta, it will be really highly appreciated for me to have this vision. Yeah.
Actually, today afternoon we have 4 o'clock. We have a program where we are discussing about the regulations. And Mr. Appavu, sir, yes, sir, we can hear you now.
Sorry, it got disconnected because of some buffering that occurred. That I have been promoted as a panelist. while clicking that, it got dragged. Okay. Coming to the, I would like to, my answers would be like to supplement Mr. Gopa's detailed explanatory webinar. And invariably, people are asking number of earth electrodes. People often forget that once we provide an earth electrode, the leakage current will go forever. It will go and dissipate into the earth and it will disappear. That's a wrong concept. Earth return path will always be coming to the source, not to the earth, the inner part of the earth. Except the lightning, which has a reference between the cloud and earth, the general mass of earth, that discharge alone go to the deep general mass of earth, not the source from transformer generators. They will all be returning to the source itself. So the very concept of TNS system is to provide an efficient earthing system. And the earth electrodes are intended for maintaining the phase to neutral. It is a reference. It's only a referencing. So as Gopa said, rightly told that providing too many earth electrodes is only giving you a mental satisfaction. Providing a TNS earthing system alone will get you a clear provision for making the fault clearing device to trip before the right time. So this is the intention of TNS, but we can't insist that you provide T and TT or IT. It all depends upon the type of installation for OT, operation theater, for computer installations, for residential installation. Most of the places we require TN system. In some industrial places, we may require TT system, as in Japan they are doing, because supply continuity is also important. And coming to the part of lightning and inspection by electrical inspectorate, I would like to say something, because you can't expect, there are 3 crore consumers in every state. I think, I don't know who raised that question. You are having only one electrical engineer for installation. But unfortunately, there are only few hundred inspectors for crores of electrical installation. You imagine how they can come, but there should be a system evolved. And the consumer, if the consumer is accountable, if they are responsible, you actually don't require even an electrical inspector for installation to come and visit. Of course, it's similar to you are not having wearing a helmet. Then why do you expect a police to stand at each traffic police station? You wear your helmet. You don't expect anybody, traffic police, to come and inspect and ask you to do it. You be a responsible person. And regarding the lightning arrestor, what I can say is, see, electrical inspector can't be expected to be a jack of, to be a master of all. You are a master of your own entity. If you are a lightning arrestor manufacturer, you will be a master in that. If you are a hospital installation, you will be a master in that. If you are a biomedical engineer, you will be a master in the medical equipment. So, but electrical inspector, he cannot become a master in every field. But in this particular specific area, there is a lot of confusion because of 2 separate and distinct earth connections and the earth electrode. The lightning arrestor flash should be run to the separately. So these are the misleading terms. I hope the CEA regulations is now amended suitably to avoid ambiguity. No doubt, the lightning arrestor's F flash should be interconnected with the equipotential body or body earth connection. Then only the loop formed by the equipment will be protected, and the lightning arrestors as well as the down earth conductor will be small and inductive drop will be less. As a result, your lightning arrestor will not become a victim during the surge diversion. Instead of protecting it, it will become a victim. So it's a science. Science can never be compromised. The rule can be changed, regulation can be changed, and the standards also, not the science. So you have every right to argue with the electrical inspector, and we are also learning from you. As you learn from us, we are also learning from you. So everybody is a learner, and there is no harm. But the standards have to strongly be appraised to the enforcers as well as the inspectors and among the people like you. The thing is, there are well-established standards. Even IS 732 is specifically saying interconnection of different components. And IEEE 142, IEEE 1100, a lot of things. So with this, I don't want to drag on much. I would like to compliment Mr. Gopa and Dominic for their wonderful.
So, thank you, Appu, for sharing your vast knowledge and experience being a chief electrical inspector of Tamil Nadu. Thank you very much. Thank you, Mr. Sanjay Mule, for joining this conversation. We look forward to continue to be part of our webinar in coming days. So I'll move on to the question from Sagar VK. What is the sensitivity of each leakage protective device for an endoscopic electrical equipment?
Yes, earth leakage protective device for an endoscopic medical electrical equipment. I really don't remember, but I can check and inform you. I think probably it's about 10 milliamperes. But
Sagar, you have... Go ahead.
Yeah, if the protective supplementary equipotential bonding is carried out, I think you already achieve a great degree of safety. But this part I will check and let you know. We are answering all these questions in our blog. So you can see the previous programs with the answers in our blog. So we will post this probably in 2 days and give you the link so that you will be able to read it. Thank you.
Sagar, in case we miss you to answer your questions later, you can always send us a mail. You can see Gopkumar mail ID and my mail ID. So we'll always will welcome to answer further queries on this. Thank you, Sagar. I'll move on to anybody. Sri Kishan. Sri Kishan, would you like to come join us for the conversation? Mr. Sri Kishan? Okay, I'll take up the next question till he comes back. Yashwant is asking, what is the specific safety measures in child ward considering fire?
Actually, the child ward, as I explained in the previous table, I don't remember exactly how it is categorized, whether it is a P1 or P2, but that is a group 0 location or group 1 location, but probably I can just check up and inform you. It is categorized as, one moment. It is categorized, the child room, there is nothing category like child room, but if it is an critical area, of course it is either P1 or P2. The safety measures which is required for P1 or P2, the group 1 or group 2 has to be implemented. There is no categorization as such like a child room.
Move on to Syed. Can we use water sprinkler? I don't know where you want to use. As I said, all the critical room of the hospital, where any scanning or MRI or CT, wherever the critical equipment are, ideally recommended to use clean agent only. So it's safe for the equipment. So, let's move on to Mahesh Desai. Is it possible during MRI that people get electrocuted? How it can be avoided? So Mahesh Desai is asking.
Yes, I think this is the sub question of the previous question which we read. So this is the correct question. Of course, yes. As I said in my first slide, you don't need to touch an equipment because medical equipment are a lot of the technical word. Let me go through it one moment. So this equipment has got the self-magnetizing, things which is internal. For its operation, it is creating a kind of magnetizing, elements are there, and it produces electromagnetics. As a result, induced currents and voltages or induced currents can happen in some parts of the installation, and it can be harmful. Yes, of course. That is why the safety measures like touch voltage reduction and all is mentioned. If those safety measures are not implemented, of course, MRI scanning machines, such as the one which you have told, it can create electrofusion. Even there are some research papers which is published. Probably I can search for it and give to you. Thank you.
Thank you, sir. Let's go to Chetan Pawar. UPS output RCCB 100 milliamp used to trip without any finding. What might be the reason?
Oh, there can be some leakage. Either your RCCB is faulty, or if the RCCB is not faulty, there will be some leakage in your wiring. See, 100 milliampere electrical, if you are connecting to one equipment, 100 milliampere leakage current, the equipment shall not create. The maximum leakage current shall be limited to less than 10 milliampere in an individual equipment of up to 32 amps current, a fixed equipment. So the answer is probably your RCCB is faulty, or probably the equipment is having higher leakage current.
Again, in continuation to SPDs, some also says that although the equipment are highly sensitive, still this concern is very well taken care by OEM itself. Necessary measures are provided by OEM in equipment designing itself. OEM is not going to rely on your installation of the equipment sensitivity when SPDs are connected, which is ultimately makes it optional or secondary. Probably answering to the question of earlier.
No, not like that. That is actually a misunderstanding. Each and every electrical equipment is supposed to withstand certain voltages, impulse voltages. The equipment vendor is providing an SPD. Imagine you have an SMPS power supply, or you have a small power supply. The power supply inherently, it can withstand only, let us say, 1 kV voltage impulse. But if you wanted to connect this power supply directly to an electricity supply from a transformer, the minimum impulse voltage withstand must be 2.5 kV. That means class 2 equipment. Sorry, the category 2 equipment, only Cat 2 equipment are supposed to be connected directly to a power supply from a transformer. Now, your SMPS power supply can withstand only 1 kV, but your equipment as such, it need 2.5 kV. What do? You install an SPD inside your equipment and ensure that your equipment is able to handle 2.5 kV. For that particular purpose, equipment vendors are installing SPDs. Don't mistake it thinking that this SPD will protect the electrical installation. No, you must require SPD at the distribution levels as well, which has to be selected and installed based on the categories of your electrical installation. Thank you.
Sanjay Malay, you can come back. I think you have one more question. You can raise your hand. My colleague Lakshmi will allow you. So meanwhile, I'll take the other question. I will take another maximum 2 or 3 questions because we are running out of time, and each questions will be answered by Mr. Gopakumar later. Individually to be answered. I'll go to Shesha Babu, who asked, how can we reduce the interference of electrical magnetic field into electronic instrument, which can be the cause of error?
Yes, see, especially in the hospital environment, the amount of EMI is very high in comparison to a normal electrical installation, because your equipment inherently are going to produce magnetism and self-inductance. So the protective measures must be implemented at the beginning of the electrical installation. Protective measures are like screening, shielding, bonding, proper routing of cables, proper separation of cables, and sometimes filters and SPDs. All these are required. So if you install those safety measures, of course, the problems due to EMI can be very much reduced.
Kulwant Singh, you're saying that self-activated fire extinguisher cum suppression, it is ideally good for electrical panel location, definitely not on the critical equipment like MRI and ICUs and other places. Self-activated extinguisher can be recommended in the room, record room or electrical room. Hope I'm clarified that. I'll go to Sanjay Mulay. You wanted to ask second question.
Yeah, Gopuma and Dominic, thanks for giving me the chance to ask second question. Now, Gopuma, we are in the business of chemical manufacturing, and we have handled lot many flammable, liquids and combustible powder in my plant. Now, as you rightly said, TNS system is effective because in TNS the fault current loop impedance is very low, the fault current very high, and the protective system operates very within time which is required. But question is that when I implement the TNS system and in my plant, if any fault happens with any equipment, when the fault current goes back to the source, that is amount of current is in Ka very high, and possibly there will be loose connection, earthing connection in plant that will create a spark, and that spark can be acting as source of ignition to the flammable atmosphere. So there is a worry for me always that whether in chemical plants where I'm handling the chemicals, wherein I'm expecting some flammable atmosphere to be happen, whether this TNS will be really helpful or it is again create a potential of source of ignition. That is what my worry.
See, when you make a TNS system, you must ensure that the loose contacts and the places where those tests are also included as a part of TNS. For example, joint resistances, sometimes it is about 0.1 ohm or even lesser, about few milliohms. So depending upon what kind of circuit breakers we are talking, or depending upon the line current. So if you are able to achieve those least impedance paths, and if the joints are thoroughly welded, which is sometimes a mandatory requirement for explosive areas, then the system is safe. If you provide a chance for a loose contact, then of course it's dangerous. So that is if there is a loose contact, whatever the system is, it is dangerous.
Yeah, absolutely. In fact, especially in chemical operating plants, where we are expecting flammable atmosphere, this is very highly dangerous. I agree with that, Gopur, but only it's a big plant, and to make sure about integrity about connections, sometimes a bit difficult because of this. But yes, I agree with you. We have to maintain the proper either you have to weld it or we have to make sure that proper connection has to be done. Otherwise, good system can go into the can be potential of creating an issue at my side. Thanks, Gopal.
Thank you.
Last two questions I will take. Sagar is asking, what is the sensitivity of an earth leakage protected device for an endoscopic?
This we already answered. No, this we already
answered. Is it?
I think
okay. Navdeep Singh, any government checking on installation and non-regular interval regarding the efficiency of equipment and quality of equipment? Any government agency checking?
Of course, there is no government checking. Especially, we are talking about low voltage installation, and mostly the electrical inspectors are responsible for voltages above the notified voltage, not low voltage. So as such, there is no government checkings. But if we look at the way the regulation is made, regulation says, every 5 years we are supposed to test at least the insulation resistance of the connected equipment. Which is a mandatory requirement by the electricity supply company. But most of the time, I think the electricity supply company is also not doing it. It doesn't mean that the supply company should come and do the test. Sometimes a contractor can do the test and submit the certificate to the electricity supply company. But all these are in paper. Only very, very few people follow it. So technically, it is the responsibility of the user. If you want a safe installation, then you have to be alert and you have to take the responsibility and do the test.
Sir, Niranjan is asking, ELCB is still necessary in IT system or for OT?
Yes, of course, yes. Because if the leakage currents are beyond a certain limit, it has to be disconnected.
Okay, the last one, if you can read out, Gopakumar, it's too technical for me to read out. please conclude this one for all. So.
Yeah, what are your thoughts about the earthing provisions for pole-mounted distribution transformer 100 kVA to 500 kVA? What power utilities or even others specify 6 to 7 numbers of earth pipe or multiple earth pipe rod? What could be the correct way of earthing at such sites of a typical distribution transformer installed pole-mounted? If, as per you said, multiple earthing pipe is not a standard method, and why it is not still implemented by even power utilities? Actually, this is a big subject which we need to take up to a higher level. If you look at the regulations, basically the power utilities are supposed to follow the regulation. As per the regulation, the power utility is supposed to give a TNCS or a TNS supply. And in a TNCS or in a TNS supply, in case of any fault on the high voltage side, the voltage appearing at the consumer premise must be lesser than certain limit. So considering all these things, the transformer HT side and LT side must be connected together first. Then from there, it can be connected to an earth electrode in soil. This is number one. Then on the distribution, there is either a fifth conductor is running as a TNS system or the fourth conductor as a TNCS network. It is called as earthed conductor or earthed neutral conductor. Then this earthed or earthed neutral conductor also has to be connected to earth electrodes in soil. I think 3 times in every kilometer or so. And the consumer premise, again, a TNCS or a TNS system has to be followed. But all these things are there in the document, but nobody follows it. Mostly the utilities are not following it. As a result, what happens is, in some of the cases where we are seeing daily, TT kind of distribution is made. Transformer HT and LT, sometimes it is connected, sometimes it is not connected. What can happen is, number one, whenever there is a fault in the consumer premise, disconnection by the fuse will not happen. That means every consumer premise, you are supposed to provide a 30 milliampere RCD. If RCD is not available or if RCD is not working, of course, the shock or fire hazard at the consumer premise is happening. This is point number one. Because the utility is not following the regulation. Number two, whenever there is a fault on the transformer HT side, multiple equipment at multiple consumer premises can fail, because whenever there is a fault on the HT side, the potential, the ground potential or the GPR is transferred to the LT equipment, low voltage equipment, and multiple equipment can fail at the same time, which may lead to again fire or other accidents. So the question, why it is not implemented by power utilities, I really don't know. Power utilities, of course, most of them are not following it. We have to ask this question to them actually, why you are not following. So over to you, Mr. Dominic. You are on mute.
Yeah, thank you, Gopakumar, and we are almost reaching 2 hours 15 minutes. Most of you, are probably thinking what is SOLVE. SOLVE stands for a safe operation of low voltage electricity. So the website details are mentioned in the chat. We would like you to visit the website, give your comment, and see how this software, which has been developed by Mr. Gopakumar, can help your facility. So that's a new launch of getting the system safe, electrical equipment safe, or electrical installation safe. So I also want to thank Appavu, who's been very patiently listening to us and attending most of our webinar. Sir, before I conclude, one good word from you, sir. Do you think that we need to continue this crusade of creating awareness on best practices on electrical safety?
Quite sure. I am fully supporting that. You should be continued for at least we should have a lot of Gopakumars. One
A lot of
Gopakumar have done.
Gopakumar in the
One
country.
Gopakumar have done propagation among nearly say 15 to 20,000 people. We got lakhs of people and repetition of because myth. There are several myths. It is very tough to erase the myth from the people. The detraining is the most important part. We have to forget what we have learned so far, and we have to learn new things. What is the correct thing? So it is very difficult to erase the wrong from the human brain. That should be done first, and I think Gopakumar is rightly doing it. I wish him all success in his full-fledged and untiring efforts. Mr. Dominic also please support. You people like you and so many people should support. I think today evening also we are having some questions which can be answered in detail. For example, noise mitigation in data centers or 18 solutions or lightning arresters. So many myths are prevailing. We have to solve those things first, and we should apprise and empower the inspectors, the engineers, contractors, these and the manufacturers. So I think our exercise will do a best thing to the country. I wish you all success.
Thank you so much, sir. As you suggested, yes, we will have one panel discussion. We have wonderful people around us. We have Bhavani Prasad, who was the CPWD Director General once, and the man who, taking care of night landing lightings and public library in Delhi, the Parliament Library that is built with best practices. So we have a good people around us, including you. We can have one good panel discussion and take more than we can take a lot of questions from the public. So what I'll do is I'll probably invite question from people before we start the webinar, and probably we take on priority, which one need to be addressed first. So we'll continue this webinar, and thank to the technology, thank to the virtual world that has given to us during this pandemic, through which we were able to touch thousands of people in last one and a half year. And I want to thank Gopakumar for utilizing this technology to spread the awareness on electrical safety. And you have become the face of this, as I said. Sachin Tendulkar means is cricket. So Mr. Gopakumar is becoming on safety crusade, awareness, the missionary of electrical safety. So I also wish him good luck, and we look forward to see you all once again. We will come back in April with another interesting topic, discuss with Mr. Gopakumar and a couple of others. We'll come back to you. And thank you so much for listening to us with so much patience. And I have almost 80% of people who attended, who joined earlier, that still remained there. And that encourages for us to do more and more. So over to Gopakumar for final comments.
Yes, thank you very much, Mr. Dominic, for your appreciation. Although thanks, Apav sir, for your appreciations. Of course, I am not a very big expert on this field. I know only probably, 20% of what is necessary. But I am still trying to learn daily, day by day, because, once when we attend the IEC meetings, after each meeting, then only I realized that, my knowledge is only even, less than 20% of what is necessary, because we have to improve a lot. And what we follow is really, especially the first point to improve is this earthing. As somebody said, this separate earth bit has to be kicked out of our nation. Then only our electrical safety will improve. So thank you very much. Thanks to all of you. Let's wait for the next session.
Thank you, sir. All of you have a great weekend and stay safe. Thank you very much. God bless you all. Thank you.